Hi everyone, and welcome to this new class in flight mechanics and specifically control surfaces. So let's begin by defining what are control surfaces. So these are basically mobile surfaces used on an aircraft in order to maneuver the aircraft itself. So basically we will be talking about three types of control surfaces. We have ailerons, which are these control surfaces located on the wingtips. Okay. We also have elevators, which are located on the horizontal stabilizer of the tail, right? And they are located on the part of the back, so on the trailing edge of the horizontal stabilizer, okay? And we also have rudders, which are located on the vertical stabilizer of our aircraft. Right, so again, ailerons on the wingtips, okay, it's important that they are as far from the center as possible in order to produce maximum moment of the aircraft. Then we have elevators on the horizontal stabilizer and rudders on the vertical stabilizer. Right, so what do we get with these control surfaces? So because we can move, the pilot can actually move these control surfaces, okay, we will be able to produce some moments, some angles on the aircraft itself. Right, so the first thing we can do is actually roll the aircraft. So create an angle of roll. This roll angle is oriented on the x-axis. Now this axis is actually the axis which relates the propeller of the aircraft, the first part of the aircraft, to the tail of the aircraft. Okay, so it's the direction of the aircraft itself. Now, rotating on the roll axis can be done using the ailerons, right? So if we produce an extra lift in one part of the aileron and we actually decrease the lift on the other part, we will be able to create a roll rotation, okay, to the aircraft. In the same way, or in a similar way, we use the elevator in order to create a pitch angle. Now this pitch angle is related to the angle of attack with respect to the wind, okay? So by creating a pitch, which can be done by the pilot, as I mentioned before, what we do is control the aircraft by going upwards or going downwards, right? We also have the yaw angle, which is an angle which will be defined as the angle on the vertical axis of the aircraft. And in order to produce a yaw angle, what we will do is actually produce some extra lift, additional lift to one direction or the other direction of the aircraft in order to change the orientation of the aircraft. Now, here we have another example, okay, of how to see this. You can see that we have the roll angle, and which will be produced because we actually use the ailerons in order to produce more lift in this part of the wing and less lift in this part of the wing. And this will create a rotation on the x-axis to the aircraft, right? So this is the roll. The yaw, as we mentioned before, is the rotation with respect to the vertical angle of the aircraft. So by changing the direction of the rudder, we will be able to create additional lift in one direction or the other direction. And this will rotate as a yaw angle the aircraft with respect to the vertical axis. In addition, you also have a pitch. Pitch will be related to changing the direction of the elevator. Okay, so the pilot will control the elevator, and by this he will be able to create additional lift in order to go downwards or to go upwards, right? So the aircraft will be controlled by these different control surfaces, and therefore we will be able to produce any kind of maneuver by combining these rotations. Now, what is the physics? Why does an aileron produce more or less lift? So it's pretty similar to the case that we discussed before, which is the flaps. An aileron works very similar to a flap. In this case, as we discussed in the case of flaps, we actually increase the lift when we put an additional wing, okay, so we put an additional part of the wing, which will be the aileron, and it is facing downwards. Okay, so it is directed downwards. In this way, what we will be able to do is actually to downwash the wind in the surrounding of the wing, right? So by doing this, by actually downwashing the wind, we will be able to produce a net force which is in the opposite direction to the downwash of the wind on the surrounding of the aircraft. Okay, so by third law and the third law of Newton, we are able to justify that the fact that the wind is downwashed will produce a positive net force and a positive lift to the wind. Okay, so in this case we will be able to produce an increased lift just because we are moving the aileron in this direction. It actually makes sense, right? It is quite intuitive. So in this case you can see that the aileron is downwashing the wind, okay, and therefore will produce an additional lift. And this additional lift will actually make the aircraft rotate. In the same way, but in the opposite way, I would say, we are actually able to rotate the aileron in this way in order to upwash the wind on the surrounding of the wing. So in this case, we will be able to produce a net lift decrease, okay, to this part of the wing. So in this way, we will actually be able to produce a positive lift here and a negative lift here, and this will, produce the balance and produce the rotation of the aircraft itself. So this is the main physical idea, okay, on how ailerons work. Now, ruders work in a very similar way. If we actually rotate the rudder in this direction, as you can imagine, the wind will be washed in this direction too. Okay, so because the wind is going over here, and when it reaches the rudder, will actually be washed on one specific direction. This wash will make the aircraft rotate in the opposite direction because of Newton's third law. So it's basic physics, okay? It is applied in many different areas. As you can see, the ailerons are able to produce a net difference in lift. Also, the rudder will produce a difference in lift on the specific lift of the rudder, okay? And this will actually rotate the aircraft. And in the same way, the elevator will actually provide a very similar forces, okay, but applied to the tail. So if the elevator is in this case washed like this, washes the wind to the top, right, up washes the wind, as in this case, so you can imagine that the lift will decrease. And if the lift decreases in this point, you can see that the aircraft will rotate towards upwards, okay, so there will be a change in direction of the aircraft. Right, so I wanted to see an example of this. Okay, so first of all, what you see here is the ailerons, which you can see are very similar to the flaps. Flaps are here, and the flaps in this case are not extended. Okay, and also the aileron is not extended, but this would be the control surface, right? And I wanted to show you this video, which I like, because you can see how the ailerons are actually used by the pilot to control the aircraft when landing. Okay, so he actually uses the ailerons in order to stabilize the direction, the roll rotation, okay, of the aircraft when landing. You can see that in this case we had crosswinds, which are winds that come at a certain direction with respect to the vertical plane of the aircraft, so coming from this direction, and he has to stabilize it in some way or another using the ailerons. Okay, you can see here how the ailerons change, right, and how he tries to stabilize it, and the aircraft won't stabilize because there's a lot of crosswind in this case. What else? Elevator and rudder are quite easy to see, to determine in various spacecraft. In this case, you can see in this aircraft, you see this is the rudder, right? Okay, it can be seen a bit. This is a control surface which can be directed by the pilot, as we mentioned before. And we also have the elevators located on the horizontal tail, right? Okay, so these are quite easy to see. You can also see, it's not as easy to see in this case, but in this case, this is a fighter, this is a Russian fighter. And as you can see, we have two rudders, okay, because the airplane is designed in a way that it has kind of two tails, or two vertical stabilizers. So two rudders to control the direction, the yaw axis direction. And we also have elevators which are not very clear to see, but they are over here, okay, and are used for pitch controls. In addition, you also have this image, which is from an old aircraft. You can also see the elevator over here and the rudder, which is this geometry over here. Okay, so with this we can move to the next class.